During this lesson on the Ground Proximity Warning System, or GPWS, we will have a look at its history, its modes of operation, and the indications associated with these modes. We will look at enhanced GPWS, the actions required on receipt of a GPWS warning, and the components in a typical system. Then we will have a very brief look at the runway awareness and advisory system. The Ground Proximity Warning System is a means of alerting crews to the danger of flying into terrain. GPWS was introduced in the mid-1970s to prevent controlled flight into terrain accidents resulting from crew errors or distractions. Prior to its introduction, there were approximately 3 to 4 controlled flight into terrain events per year, killing hundreds of people. After GPWS was introduced, there was a major reduction in the number of controlled flight into terrain accidents. GPWS has a height operating band of between 50 and 2,450 feet actual height above the surface, and automatically selects the correct mode of operation. The crew are informed by means of visual and audible warning signals when the aircraft's proximity to terrain poses a threat. We will now look at the individual modes of operating, starting with Mode 1. This gives us protection against excessive barometric descent rate. It has 2 boundaries and is independent of aircraft configuration. Penetration of the first boundary generates an oral alert, which is repeated every second and a half.
Sink rate.
Penetration of the second boundary generates a visual and audible warning until the rate of descent has been corrected.
Pull up.
Mode 2 has inputs from radio altitude rate of change, Mach number, barometric altitude, and aircraft configuration. It also has 2 boundaries. Crossing into the first boundary causes an oral alert.
Terrain.
The caution boundary is so small that almost instantaneously it will be followed by a visual and audible warning.
Pull up.
After leaving the pull-up area, the audible alert will again be heard while in the terrain segment.
Terrain.
If both boundaries are penetrated in the landing configuration, then only the repeating audible alert message is heard. This is repeated every second and a half.
Terrain.
As speed increases to between 220 knots, or Mach 0.35, and 310 knots, or Mach 0.45, with undercarriage up, the highest radio altitude at which Mode 2 operates is increased to 2,450 feet. This higher portion is inhibited with the flap override switch in the flap override position. Mode 3 provides an alert if a descent is made during the initial climb or go-around. Mode 3 is effective between 50 and 700 feet radio altitude and generates the alert when the aeroplane has descended by 10% of the existing radio altitude. It is not armed during the approach until below 200 feet radio altitude. The oral alert is repeated every second and a half until the flight condition is corrected.
Don't sink.
Mode 4A is protection against unsafe terrain clearance when the undercarriage is not down. The system is armed after takeoff and after passing through 700 feet radio altitude. When the aeroplane subsequently descends below 500 feet radio altitude and at a speed of below 220 knots, or Mach 0.35, then the oral alert "too low gear" is heard and repeated every second and a half with the visual indication "pull up."
Too low gear.
With an increase of speed, to above 220 knots, or Mach decimal 35, the boundary is increased to 1,000 feet radio altitude, and the aural alert changes to too low to rain. It is also repeated every second and a half.
Too low to rain. Too low to rain.
For Mode 4B to activate, the undercarriage needs to be in the down position and flaps not in the landing position. If the aeroplane then descends below about 250 feet at a speed of less than 190 knots, or Mach decimal 28, then the aural alert, too low flaps, is sounded, along with the visual pull-up warning.
Too low flaps. Too low flaps.
If the aeroplane's speed is above 190 knots, or Mach decimal 28, then the height range is increased to 1,000 feet, and the aural alert becomes too low to rain.
Too low to rain. Too low to rain.
In both Mode 4A and 4B, the message is repeated every second and a half until the condition has been corrected. The too low gear alert takes priority over the too low flaps, and both can be inhibited by use of the flap gear inhibit switch. A Mode 5 alert is issued when the aeroplane descends more than 1.3 dots below the glide slope. Mode 5 is armed when a valid ILS signal is being received by the captain's glide slope receiver and the radio altitude is below 1,000 feet. There are two areas of alert, soft and loud. In both areas, the alert is a repeated glide slope call and the illumination of the below glide slope light.
Glide slope. Glide slope. Glide slope.
In both areas, the voice message repetition rate increases as the glide slope deviation increases.
Glide slope. Glide slope. Glide slope.
In the loud alerting area, the voice message amplitude is increased.
Glide slope. Glide slope.
Mode 5 can be cancelled or inhibited by pressing either pilot's below glide slope light while below 1,000 feet radio altitude. It will rearm again on climbing above 1,000 feet radio altitude. Modes 1 to 4 aural alerts have priority over Mode 5 alerts. However, both pull-up and below glide slope lights could be illuminated at the same time. Mode 6A operates between 50 and 1,000 feet and provides the crew with an aural warning if the aeroplane descends below the minimum decision height as set on the captain's radio altimeter. The aural alert minimums sounds only once and will be rearmed when the radio altitude becomes greater than that selected.
Minimums.
Mode 6B adds two further safety features to the GPWS system and consists of height callouts on approach and bank angle alert.
500. 100. 50. 40. 30. 10.
Bank angle is to warn crews of excessive roll rates. The bank angle limit reduces the closer to the ground the aeroplane is because of reduced wingtip and engine pod clearance.
Bank angle. Bank angle.
Mode 7, which has priority over all other modes, provides the crew with visual and aural alerts and warnings when entering a potential wind shear area. To achieve this, it requires inputs from ground speed, airspeed, barometric height, rate of descent, and radio altitude. The system reacts to the onset of wind shear conditions. This allows crews to initiate the escape maneuvers earlier, giving them a greater chance of avoiding a potential accident.
wind shear, wind shear, wind shear.
If an aeroplane continues into the wind shear area, then visual and aural warnings are issued. The red wind shear warning illuminates, and wind shear, wind shear, wind shear is announced.
Wind shear, wind shear, wind shear.
We will now take a brief look at enhanced GPWS, sometimes called eGPWS. The reason this system was introduced is because the original GPWS could not anticipate terrain ahead of the aeroplane, and consequently, when approaching a hill rising rapidly from the terrain, it would not produce a Mode 2 warning. What was introduced was enhanced GPWS, and this includes a World Terrain Database, and is sometimes known as a Terrain Awareness and Warning System, TAWS. To enable this system to function, it has to know the position of the aeroplane, so is dependent on the accuracy of the aeroplane's navigation equipment. The system provides both visual and audible warnings of terrain. Visual warnings are displayed either on the weather radar, navigation display, or on the warning system's own planned position indicator. The terrain is displayed using the colours green, yellow and red. When approaching terrain ahead, the terrain colour changes from green to solid yellow, and an aural alert is given.
Caution, terrain, caution, terrain.
If the aeroplane continues towards the obstacle, then the terrain colour changes from yellow to red, and an audible warning is given.
Terrain, terrain. Pull up.
In addition, a terrain clearance floor has been developed around all airports to warn against potential premature descent on non-precision approaches, like VOR NDB approaches. We will now look at the actions required on receipt of a GPWS, eGPWS warning.
Pull up.
The action should be immediate and positive, and is to roll the wings level and initiate a maximum gradient climb, which should be maintained until the aircraft is above the minimum safe altitude for the part of the route being operated. Once established in the climb, then and only then should the crew look into the reason for the warning and verify the aeroplane's actual position. The only circumstances when a climb to safe altitude may be discontinued are when the cause of the warning has been positively identified or the warning ceases. The pilot must not deactivate the system unless told to do so by the operations manual. The airline operator should be informed of all warnings, even nuisance or false alarms, so that remedial action can be taken so as to maintain confidence in the GPWS system. The two times when the GPWS, eGPWS would need to be inhibited occur during the approach phase. These are either if the flap gear positions are known to be non-standard, or if the crew are flying in an approach without regard to the glide slope. We will now look at the components in a typical GPWS, eGPWS system, and we start with the brains of the system in the central processing unit. Into the central processing unit are various inputs from the radio altimeter for actual height above the ground, Mach meter, air data computer for all the barometric information, glide path deviation, undercarriage, and flap positions, and finally, input from the navigation system. The central processing unit takes the inputs and then produces either an alert, this is a caution generated by the system, or a warning, which is a command generated by the system. This is then sent back to the necessary output, including the master indicator, visual warning, and audio warning. The final part to GPWS is the runway awareness and advisory system, which was introduced to help reduce the number of runway incursions. The system has a database of all airport layouts, so combined with an accurate navigation positioning system, like GPS, it enables the system to know where the aeroplane is in relation to runways and taxiways. It helps improve a crew's situational awareness when in the vicinity of an airport by issuing various oral alerts during taxi, takeoff, approach and landing. During this lesson, you have seen the different modes of operation of the Ground Proximity Warning System, GPWS, when they apply, and the different configurations required to trigger a warning or alert. You may wish to take some time to study the table before continuing. You were also shown the reason that the Enhanced Ground Proximity Warning System, sometimes known as the Terrain Awareness System, TAWS, was introduced. Next, you saw the required actions to be taken in the event of a GPS warning or alert, and the components of a typical GPWS system.